Mega Worrk.
The Tuen Mun Chek link is a critical northern connection for Hong Kong's transport. Marine surveys begin across the Urmston Road corridor to map the complex subsea environment. Onshore, engineers establish precise survey control lines to guide the future tunnel's starting point. Geotechnical drilling platforms collect core samples from the seabed to analyze the mixed ground. Final boundary markers are placed along the shoreline, defining the project's northern landfall zone. Material barges deliver engineered fill to the coast, beginning the massive land reclamation process. Heavy dozers and excavators redistribute the new fill, shaping the site's initial work platform. Motor graders trim the surface to exact elevations, preparing the ground for deep construction. Massive vibratory rollers compact the fill layers, ensuring a stable foundation for the launch shaft. Crews install temporary drainage and access lanes, completing the handover of the reclaimed site. Final settlement checks verify the platform's stability before the start of deep shaft works. Barriers and staging zones are organized around the site, marking the transition to excavation. Technicians construct shallow guide walls that define the unique peanut-shaped footprint of the shaft. A heavy diaphragm wall rig begins excavating individual panels, supported by a specialized slurry system. Large reinforcement cages are lowered into the panel trenches with extreme precision by crawler cranes. Tremmy concrete displaces the support slurry, forming the permanent perimeter of the massive launch shaft. Bulk excavation commences inside the completed walls, removing soil lifts in a controlled sequence. Structural bracing is installed at various depths to maintain the integrity of the shaft walls. The shaft base is cleared and reinforced, creating the cradle for the tunnel boring machine. The first massive shield component of the S880 machine is lowered into the launch lobe. A second massive curved shield shell section is lowered and aligned, closing the outer cylindrical shield. The central drive module is lowered into the shield, converting the structure into a functional machine. The enormous cutter head is rotated and moved into position, preparing for final mechanical connection. The cutter head is mechanically connected to the drive interface, completing the primary assembly phase. Trailing gantry modules are connected sequentially, establishing the TBM's extensive support and logistics system. Slurry hoses, power cables, and ventilation services are integrated, preparing the machine for active commissioning. Engineers perform stationary functional tests of all systems to verify readiness for the first drive. The S880 begins its first controlled excavation stroke, advancing into the northern approach mixed ground. Following the first stroke, the erector positions the initial lining segments behind the shield body. The first structural ring is closed, providing the necessary reaction for subsequent excavation cycles. Hydraulic cylinders react against the new lining, pushing the machine forward in a continuous cycle. The southbound S882 begins its parallel drive, ensuring synchronized progress for the twin tunnel system. S880 successfully breaks through into the north ventilation shaft, completing its approach drive segment. The large machine is dismantled, while a specialized, smaller TBM is assembled for the subsea drive. Motor graders trim the surface to exact elevations, preparing the ground for deep construction. Sealed slurry circuits transport excavated mixed ground away from the pressurized face at the subsea front. Return pipelines convey excavation slurry back toward the northern landfall for specialized surface treatment. At the surface, the treatment plant separates coarse solids from the slurry in the first processing stage. Advanced dewatering systems compress the remaining fine material into stackable cakes for controlled removal. Logistics vehicles maintain a constant supply of new lining segments to the active tunnel front. The erector rotates the next segment into position, continuing the precise structural assembly of the bore.
Standard segments are sequentially installed, forming the circular wall beneath the Urmston Road corridor.
The final key segment is inserted, locking the ring and completing the tunnel's primary structural shell. With the ring complete, thrust resumes, advancing the machine through the mixed alluvial geology. Independent work fronts in the northbound and southbound bores ensure redundancy and steady project completion.
A smooth production rhythm is maintained as the machines approach the deeper sections of the crossing.
Cutter monitoring systems detect early signs of wear, prompting a controlled pause for non-invasive assessment.
A remote inspection device is deployed into the pressurized zone to visually assess the cutter conditions.
Robotic handling systems are utilized where possible to perform cutter replacements without manned intervention.
Hyperbaric habitat systems are prepared and tested to allow crew access under controlled pressure conditions. The maintenance crew transfers through the sealed system, entering the pressurized front for manual intervention.
Under stable hyperbaric conditions, worn cutters are replaced to maintain the TBM's excavation efficiency. Once serviced, the maintenance zone is resealed, allowing the machine to prepare for resumed excavation. In difficult ground sections, additional stabilization is required before maintenance can be safely performed.
Liquid nitrogen freezing systems are installed to create a stable, frozen ground barrier around the machine.
Controlled nitrogen circulation begins, gradually cooling the target zone to prevent ground movement during intervention.
The stabilized ground allows for safe cutter replacement in geology that was previously unmanageable. With maintenance complete and ground stabilized, the TBM resumes its path toward the southern landfall. Transverse cross passages are prepared by establishing reinforced launch interfaces within the completed main bores. A compact mini TBM is aligned transversely to the main tunnel axis to excavate the connection. The mini TBM begins its drive through the intervening ground toward the parallel neighboring bore. Pipe jacking techniques extend the cross-passage tunnel string, maintaining a precise and stable connection. The mini TBM completes its breakthrough, creating a physical link between the twin road tunnel bores. The machine is recovered, leaving a secure and watertight transverse tunnel ready for final fit-out.
At the southern landfall, an articulated multi-cell cofferdam system manages the deep cut and cover transition.
Excavation and structural bracing proceed in stages, maintaining stability as the southern approach deepens. Permanent concrete structures are initiated within the cofferdam, preparing for the bored tunnel's arrival. The Subsea TBM completes its final arrival, successfully linking the bored tunnel to the southern landfall. A continuous structural connection is cast, uniting the circular bore with the southern approach structure. Tunnel fit-out begins with the installation of overhead ventilation slabs to manage future airflow. Modular service gallery elements are positioned beneath the future roadway to house critical utility corridors. Permanent fire services, cable trays, and drainage systems are integrated into the tunnel's service infrastructure. Final roadway finishes and lighting fixtures are installed, transforming the bore into a functional highway. Integrated commissioning verifies all systems are operational before the tunnel is open to public traffic. The Tuen Mun Chek link stands complete, a testament to world-class subsea engineering.
Mega Works.